Okay, hopefully you understand the concept of probability. You're trying to predict the chance of something that's happening. So there's some online little games we can look at. Some of them are kind of easy to understand. Like when I say start the game, they're giving me a spinner at which I want to choose the one that's going to give me the greatest chance of winning. So, would it be the probability that I would roll or spin a green or a yellow, or green, red, or yellow, green or red, or blue and red? So, when you're looking at it, you're looking at the one that's going to give you the greatest area on that spinner. So, you naturally would eliminate green or yellow since this put green, yellow, or red. So, green, yellow, or red would be the one that would give me the greatest chance just because I have more of those. So, when you're spinning it, it'll let you know whether you win. Now, you're not guaranteed to win, um, but you could. So on this one again, pick the one that has the greatest area. So you've got quite a bit of blue, you got quite a bit of yellow and red. Now, if I actually wanted to find the probability exactly of me being able to spin one of these, the first thing I'd have to do is I'd have to start counting how many pieces there are. So this is starting off number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 total parts. So however many total parts you have, that's going to be your denominator. Now, if it says what's the probability that I would spin a yellow, then you just count how many yellows it is. So the probability it's a yellow would be 2 out of 16. So this would be 2 out of 16, which is not very good chances of that happening. Now, what about green or red? I've got 1, 2, 3, 4, 5, 6. So that would be 6 out of 16. And as with all fractions, it's usually better to go ahead and reduce in simplest form because if it's 2 out of 16 chances, it's sometimes easier said 1 out of 8. That puts it in a little bit different perspective. Same thing with 6/16. You divide them both by 2, then you have a 3 out of 8 chance. So you have a greater chance of getting green or red than you do yellow. So let's go on and say blue or yellow. So count your pieces of blue and yellow. So you got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be a 9 out of 16. And then this is blue, yellow, or red. So I've already counted blue and yellow, so I've just got to add the red to it. So there's 2 more red, so that'd be 11 out of 16. So just kind of common sense, the more that you have of something, the greater the chance that you're going to end up getting it. So when you're doing the uh, evaluating statements about probability, you're looking at what you have. You've got 2 bags, A and B, and they both have red and yellow jelly beans. But there are more red jelly beans in bag A than there are in bag B. So if you choose one jelly bean from each bag, I am more likely to choose a red one from bag A than from bag B. Well, that naturally would be true. So on this little MFAL, you are to go around and figure out if the statement that they're giving you is true, false, or unsure. So again, work with a partner on this and try to sort it to where you would figure out what it would be. So your directions I kind of put there. So try to convince your partner what your decision, discuss your reasonings together, and then glue it on um, a column that says true, false, or unsure, and then give a reasons to why you put the card in the column that you did. So good luck on that one.